Hello everybody, this is a quick demo of our do-it-yourself MIDI controller. The MIDI controller has 16 encoders. These are push encoders with an LED ring around them, and you can push them to change the mode of each controller. This is completely programmable, open firmware, so anybody can get this and go to the GitHub and get the source code for modifying it. There is also a simple web-based configuration program. It by default comes with a MIDI application inside it, where you can actually map all the keys, all the encoders and modes directly using that web app. So you can configure it as a standard MIDI controller. So after this, we have 16 keys. These are cherry keys with the keys and the keycaps being modifiable. There are 2 shift keys over here, which allows you to change the function of each and every key. It also comes with a display. This display can be used to show any information regarding the synthesizer or MIDI mappings and things like that. So let's look at what is in the back. We have a special key. This is basically a special shift. This is primarily kept separately so that you don't press it accidentally during a live performance. For example, you can press this and press the menu key to go into the settings of the actual unit. So there is a USB host port. The host port allows you to connect it to other MIDI controllers, surfaces and things like that. And you can actually use this as a MIDI filter. So one of the applications that we are actually using this for is you can actually map any keys of a MIDI keyboard to a particular scale. So you only play in C major scale, but you can map it to, for example, a C minor scale or a D minor scale. So when you use the keys, C major keys in your MIDI keyboard, it will map automatically to a D minor scale. And then you can also do things like, for example, quantization. If you're doing something like a DJ, and you can actually set up the quantization in this unit so that the MIDI keys only reach there at the correct quantization period. So it has like a bunch of applications like that. So that's the reason you have a host port. Then you have the DC jack. After the DC jack, we have the USB host port. This is connected to the computer. This is where all your MIDI keys come in. We also have an SPDIF controller over here. This is where you connect your DAC. So when you program this unit to be a synthesizer, you can actually connect a DAC to this. And we have a MIDI in and a MIDI out connector. These are DIN connectors. We have 2 more MIDI in and 2 more MIDI out, which are actually can be brought out and connected to a TRS connector. So this is actually designed to be a completely open platform. The code for this entire thing is available in GitHub. It also has information about how to put this together. So if you actually look at it, this is built modular. These 4 controllers are one board. So you can actually extend it as big as you want horizontally. And similarly, this entire key set is one module, so you can actually extend it as big as you want. Similarly over here, so that way you can actually build a controller as big as you want or as small as you want. For example, if you want a simple controller with just one display and say, for example, 4 keys like this, 4 keys over here and 4 encoders, you can do it. So this whole unit is completely modular. You can look at the GitHub site to get information about how to build it yourself. The whole thing is based on Teensy 4.1. In the next few videos, I'll show you the internals, how the whole thing works, and the Teensy board and things like that. Thank you.